Kia ora Year 12. This is going to be a short video that goes through how we solve linear inequalities, or more properly called linear inequations. And these are things that you first saw back in Year 10, but this year they're going to be a little bit more complicated. So Walker pages 41 to 42 has lots of really good examples of these. Let's first of all go all the way back to a number line from, I don't know, Year 6 or Year 7. And I think if you start with this kind of basic fact, it's going to help with your understanding. So let's mark 0 on our number line and just two numbers. So here's 2 and here's 6. So we can see here that 6 is bigger than 2. But if we work backwards now to the negative values, we've got -2 here and we've got -6 here. So -6 is less than -2. Now that's kind of obvious, but what that means is that when we come to multiply or divide, we have to switch that sign over when we're multiplying or dividing by a negative number. So let's start with a really simple example. If I've got -2x is greater than 8, that means that I'm trying to figure out what numbers will give me something bigger than 8 when they're multiplied by -2. So let's just do that by having a look. If I put in x equals 5, that's going to give me on the left-hand side -2 times 5, which is -10, which is not bigger than 8. So that's clearly not going to work. What if we've got x equals -5? Well, that will work because -2 times -5 is going to give me +10, which is bigger than 8. But we don't want to do that every time we have a linear inequation. Instead, what we want to do is the same thing to both sides. So if we had -2x equals 8, all we would do to solve that is to divide both sides by -2. And we'd have 8 over -2. And we'd simplify that to get x is equal to -4. So -4 is still important when we've got the inequation. Here's what we're going to do. We're going to divide both sides by -2. So we're going to have x is less than 8 divided by -2. We're dividing by a negative number, so we have to switch the inequality. So we get for our answer x is lower than or less than -4. And you can see that fits with one of our values that we know is in the solution set here. So x is less than -4, and we could draw in that solution set as follows. So -4 is not a solution, but all the numbers below it are. And you might remember doing that a couple of years ago. What I want to do today is to review some slightly harder examples, and then you can go and do the Walker exercises. So these come up quite often in the Level 2 algebra exam, but they're also a good lead into quadratic inequalities, which we're going to look at next. So 2x minus 1 equals 4 is a simple equation. So for that, we're going to add 1 to both sides. We get 2x equals 5, x is equal to 5 over 2. Over here, we've got the inequation. So we have 2x minus 1 is less than or equal to 4. We add 1 to both sides. We don't have to change the sign. And now we divide both sides by 2, and we still don't have to change the sign. So my answer is x is less than or equal to 5 over 2. Now we can check that that works by taking a value that's in that solution set and checking that it really is a solution. So if we take x equals 0 and we substitute it in here, we get 0 minus 1, which is -1. And that is less than or equal to 4, so that looks good. Okay, a couple more really easy ones before I go on to some fraction ones. So -4x equals 8, x is equal to -2, right? So that's dividing both sides by -4. Now let's turn to the inequation. First I'm going to subtract 5. I get -4x is less than 8. And now I'm dividing by -4, so I have to switch the sign. So it's going to be x is greater than 8 over -4. We need to simplify that, so we get x is greater than -2. And again, we can check that that works because x equals 0 should be in the solution set. Substitute it in here, and we get 5 on the left-hand side, and 5 is less than 13. Okay, now on to one where we've got to simplify some fractions. So we're going to clean up this left-hand side first, and then proceed from there. The common denominator I'm going to get here will be 35. So we've got something over 35 plus something over 35. I times 5 by 7 to get to 35, so I have to do the same to the 2x. So that gives me 14x. Right, 7 watts are 35, 7 fives, so 3 times 5 is 15, and it's 15x is less than 10. So cleaning that up gives me 29x over 35 is less than 10. That gives us 29x is less than 350. Right, so I'm not changing the sign because I'm multiplying by a positive number. And lastly, I'm going to divide both sides by 29. So I still don't change the sign because I'm dividing by a positive number. And that's my final answer there. Okay, next question. Another fractional one. But here, I've got x minus 3, all divided by 4, is greater than or equal to 6x plus 1. So I can treat this as being in invisible brackets. The first thing to do is to multiply both sides through by 4. We'll get x minus 3 is greater than or equal to 4 times all of the right-hand side, which gives me x minus 3 is greater than or equal to 24x plus 4. Now, cleaning this up, there are a couple of ways I can go. I'm going to look at, I've got 24x here and I've got x here. So I'm going to subtract x from both sides. That does not change the sign, right? Subtraction and addition don't affect the inequality. So here I'm left with negative 3 is less than or equal to 20, let's see, am I doing this right? Yep, that looks right. So I've got negative 3 is less than or equal to 23x plus 4. Right, so we're down to here. Next, I'm going to subtract 4 from both sides. So I get negative 7 is greater than or equal to 23x. Negative 7 is divided by 23 is greater than or equal to x. So I haven't changed the sign because I've divided by a positive number. But now, this looks really silly to me. This says negative 7 over 23 is bigger than x. We usually write it as x is something. So here x is less than or equal to negative 7 over 23. Okay, last one. I need to get a common denominator on the left-hand side, and it's going to be 12. So multiplying both sides by 3 gives me 9x by 3 over 3 minus, what do I have to do here? Well, I've times the 3 by 4. So I have to multiply this by 4. So it's going to be minus 16 times x minus 1 is less than 10. Cleaning this up is where I've got to be really careful. I've got 9x minus 16 times x minus 1 is less than 10. I could take one of two next steps here. I think I'm going to multiply through both sides by the 12 first. So I'll get 9x minus 16 into x minus 1 is less than 120. 9x minus 16x plus 16 is less than 120. Negative 7x plus 16 is less than 120. I'm doing every little step here, guys. So you could go from here down to this line. So negative 7x is less than 104. So notice that this inequation, or this inequality sign, is not doing anything to make this harder at this stage. The only time I've got to think about it really hard is where I'm dividing or multiplying. Right, so I'm about to divide by a negative. That means I've got to switch over the sign. So x is greater than 104 over 7, and I just leave my answer like that. Okay, I think that's probably enough to get you started. So go do the exercises on pages 41 and, whoops, where's the start page? 41 and 42 of the Walker book.